Okay, so we are moving on to chemistry section 2.4. We have skipped chemistry section 2.3 just based on time. If you are interested, you can go back and look at it. I believe it is on factors affecting reaction rate. This week's videos are 6 short videos looking at 6 different reaction types. And then there is some practice to make sure you fully understand it to move on. First part here is the key concepts. I'm just going to slowly click through these. Again, you should already hopefully have this done. If not, please pause, copy these down if needed. Pause if needed to copy them down. You should copy them down. Okay, and some key vocabulary. Again, you should have this already done. These aren't filled in here, so I'm just going to move on to the lesson. Types of chemical reactions. Specifically, we are looking at synthesis reactions, and this corresponds to page 160 in your textbook. So the first type of reaction that we are going to be looking at is what is called a synthesis reaction. It may also be referred to as a formation reaction. So 2 or more reactants, usually elements, join to form a compound. So it is possible that it does involve smaller compounds instead of elements, but it's usually elements. So letters are used to represent our elements, to keep it really general. A being the first element, B being the second element, and then they combine together to form a new compound, AB. So this is basically 2 elements coming together to form a compound. So element plus element produces compound, nicely symbolized here by the color red and yellow making orange. Okay, so synthesis of ionic compounds. Synthesis reactions may form ionic compounds, and remember that an ionic compound is a metal plus a nonmetal. So these 2 things are combining together. Sodium metal and chlorine gas combine to form sodium chloride. And we do have an image of that in the top right corner. So you can see that there's kind of a yellowish green gas. And then those combine together to form the sodium chloride with the sodium metal in it. Sodium chloride is obviously regular table salt. This is probably a compound that you're very familiar with. So sodium metal plus Cl2, remembering that Cl2 chlorine is diatomic. It's part of the Hoberfinkel acronym. So when these combine, it gives us NaCl. So that's our skeleton. And then we need to balance this. So 2 parts sodium combining with 1 part chlorine gives us 2 parts sodium chloride. Okay, and then when we look at magnesium metal reacting with oxygen gas to form magnesium oxide, it is oxygen gas again is O2, it's diatomic. Magnesium oxide, MgO. This is the skeleton, so then written out for you on your example here, we've got the balanced equation here, so both of these are balanced for you. So it is 2 parts magnesium metal with 1 part oxygen gas gives us 2 parts magnesium oxide. Synthesis can also occur with covalent compounds, remembering that covalent is 2 non-metals. So elements may form covalent compounds like the following. So nitrogen gas and oxygen join to form dinitrogen monoxide. So formula here, N2, again part of Hoberfinkel, plus O2 produce N2O, or dinitrogen monoxide. So again, we need to balance. So we've got 2 parts nitrogen gas plus 1 part oxygen gas gives us 2 parts of the dinitrogen monoxide. So this is made up of 4 nitrogens and 2 oxygens if you were to actually count the atoms involved in that compound after it was balanced. Nitrous oxide is the more casual name for dinitrogen monoxide. The image shows the actual process needed in order to make dinitrogen monoxide. So it's not quite as simple as it seems based on the chemical reaction. So an analogy for synthesis reactions: two people meet, they become a couple. So you think of that one couple that when they start dating, they are absolutely inseparable. They're glued together, they do everything together. They are essentially one unit. So made up of two people. One individual plus another individual come together, they become a couple. And this could be ionic, which works well with the whole male-female imagery, or they could be covalently bonded, which would be, the parallel would be a male-male reaction or a female plus female, I shouldn't say reaction, couple. Okay, so some practice problems for you to work through and check your understanding. These answers will be posted on Teams. We have a ton of practice throughout this because just like math, chemistry needs a ton of practice to understand and make connections.